Dear students, in this presentation, we see another type of queue called circular queue. What are the different operations that are involved with the circular queue? Later, at the end of the presentation, we'll see how to design a dynamic circular queue. Before taking circular queue, we'll see why circular queue is required. What are the problems with the ordinary queue? When or in which situation ordinary queue or the linear queue fails. With examples, let us take the linear queue whose size is 5. Okay. Initially, the front and the rear value both set to -1. That condition is called the initial condition or the emptiness of the queue. Initially, front value is -1, rear value is -1, and that condition is the empty queue. We call this condition as empty queue, empty ordinary queue. When queue is empty, we can't perform deletion fails. So condition that is to be checked for performing deletion is when front is -1, rear is -1, they should not be -1. If front is not -1, rear is not -1, then we can perform deletion operation. Now we'll go for one more operation, that is insertion. When we perform insertion, the front index will not be changing, same, only rear is getting modified. So the rear value is incremented by 1, in that place new element is inserted. So the front value is same, rear value is incremented by 1, it now becomes 0. The operation that is performed is insertion. The item say 10, item that is inserted is say 10. The, it is success, insertion is success. The 10 element will be placed in the queue. Only rear is getting moved. Front C. This is the condition of the linear queue after performing the insertion. Let us take one more operation. Operation is again insertion. As we discussed earlier, the front is not changing, front remains same, rear is incremented by 1, the current index is 0, now it is 1. The operation that we perform here is insertion. The item that is inserted to the queue is 20. So insertion is success. Insertion is success because the condition that we need to check is whether rear value is less than max minus 1 or not. So it is not full, the condition is empty, is full must be used here. In case of insertion, the condition that is used to check is full. Here Q is not full, so we can perform insertion. So the item inserted into the queue is 20. Here, here the index that is rear is moving by one place. It's moved by one place. We'll take one more operation again. Again, the operation is say insertion. This is same. The front index is same. Only rear is getting modified. Becomes 2. Operation is insertion. Say item that is inserted is 80. Say. And the operation is success. Insertion is success because it is not a full. That item will occupy this place. Item is at 80. the pointer is moved by one place. The index of the last inserted element indicated by rear. So index is 2. This is the rear pointer. We'll take one more operation, that is a deletion now. We'll go for deletion. We'll go for deletion. It has to be checked first whether queue is empty or not. As queue is not empty because print is -1, okay, read is not -1. That is why queue is not empty. So here we'll add that condition here afterwards. Is empty false. So we can perform deletion. It is not empty queue. Can perform deletion. The first element that is inserted to the queue is removed first. The first element inserted to the queue was 10, so that will be removed. The index of that item is 0. So now that in that we also we can say our front is incremented by 1, -1 becomes now 0. Rear is not changing, it is same. The operation that we performed here, it is deletion. The item that removed is 10. Deletion is success. Deletion is success. That means this item gone. The 10 gone. This is a pointer that is moved by one place. It is a rear pointer, it is a front pointer. We'll go for one more operation. Like insertion, I have to check whether queue is full or not. Is full or not. Again, it is false, it is not full, so we can perform. During insertion, front is not changing, only rear is modified by 1, 3. Here what we perform, operation is insertion, inserting item, say 100. 100 is the new element that is inserted to the queue. 100 is inserted here. It is possible to insert the item. Then the pointer is moved by one place. The rear pointer is now pointing to the last insert element index, that is 3. So insertion is success. Insertion is success here also. We'll try one more operation. Again insertion. I want to perform insertion again. Queue is not full. Still there is a place. That is why is full is called. Is full is false. It is not full. Only front insert front only the rear is updated. Front is remains same. Front now pointing to the last inserted element place, that is 4. Operation, that is insertion. Item is 60. Here also insertion is success. Item inserted is 60. This pointer is moved by one place. Okay. Now when we try insertion, I will try insertion again. Now what happens? It checks whether queue is full or not. Is full becomes true. Front remains same. Is same. We are trying to perform insertion. Say inserting element 30. And this fails. Insertion fails. It fails because is empty, is full is true. So this is the drawback. As you can see, there is a place here, but we're not able to insert the element. This is because we are checking is full condition. Is full will be true if rear reaches max minus 1. Here max value is 5, max minus 1 is 4, rear value is 4, so it is full. So this is the drawback of ordinary queue. So the condition that used here is one is full. It is true when rear equal to max minus 1. In this case, it is true because rear value is 4, max value is 5, 5 minus 1 is 4, 4 and 4 are same. Is empty returns true when rear equal to minus 1 and front equal to minus 1. So these two conditions must be used during insertion or deletion. So there is a problem here. There is a place, but we are not able to insert. So when rear pointer reaches to the maximum after deletion, we find some places in the queue, but algorithm doesn't allow us to insert. This is a drawback of linear queue. That can be solved with the help of a small arrangement where the maximum the index with if reached, then that will be reset to 0. Like front or rear if reaches 4, next time that is made to 0. It is set to 0. It is reset to 0. That means this is changing in circular fashion. If there are 5 numbers, the size is 5. The index value ranges from 0 to 4, then again 0 to 4, like that it rotates. Always index starts from 0 till the maximum, then again that is reset to 1. Now we see the operations in case of circular queue. Like earlier, the initial value of front is minus 1, that is same. Rear is also minus 1, same. This case is called empty case, empty circular queue. Okay. Circular queue is said to be empty if front equal to minus 1, rear equal to minus 1. That condition is safe, is empty, is empty. Returns true if front equal to minus 1 and rear equal to minus 1. This is one of the conditions that must be checked for empty. This is useful for deletion. We have to perform deletion, we have to see whether queue is empty or not. Here deletion will fail because it is empty. We'll try that one. The condition to be checked is empty. Is empty is fails. Is true. Is empty is true. This is same. Front is same. Rear is minus 1. It is also same because we are not able to perform insertion or deletion. Both remain same. This condition is called underflow. This condition of the queue is called underflow because we are not able to perform insertion or deletion. Deletion fails. Underflow. Deletion fails. Now we'll go for insertion. We're going to perform insertion. Queue is not full. As you can see, queue is not full. We'll give the condition a little later. Queue is not full. We can perform the operation. Queue is not full. We'll write that later. Front is not changing. It is same. Rear is updated by 1. It is 0. The operation that we perform here is insertion. item that is inserting is 10. Okay, it is success. You can insert new item. That item will come to this place. This is the insertion. The front value is same, rear value is 0. Insertion success because queue is not full. Go for one more operation. Still there is a place we can perform insertion. So in that case, this is minus one. Front is not changing because operation that we are performing is insertion. Here it is changed, incremented by 1, incremented by 1. The operation performed here is insertion. Item that we are going to put into the queue is say 20. This is success because there was a place, that place new item inserted. So the 20 comes to this place. Like that it goes. So when we insert 30 here, the front value remains same, rear value is 2, the operation is insertion, the item inserted is 30, it is success. Okay. Next we will go for the deletion. In that case now this element will be removed, 10 will be removed. So front is incremented by 1, it is now 0. Front is 0 because queue is not empty, is empty, it is fail. Front is minus 1, rear is minus 1, false. So we can perform deletion. This remains same. The operation is deletion. Item removed is 10. It is success because the operation success because it is not empty. Is empty is false. This item is removed. We'll go for one more operation, that is insertion. Again we'll go for insertion. Item to be inserted is a 40. Can perform insertion. Only rear changes, front remains same. The item comes to this place. Similarly, we can perform one more insertion. Operation is again insertion. That item will go to the fourth index. Front remains same. This item is 50. We are able to insert. That item will come to this place. Here, as you can observe, there is a place. Unlike in linear queue, the index is now changing from 4 to 0. It is now reset to 0. The next position is 0. It is not 5. It is not the next index, it is reset to 0. So we can perform insertion. In that place, the new element is inserted. So front remains same. This 4 is now reset to 0. How to do that programmatically, we'll tell little later. Insertion, the item insert is say 60. It is success. Success. 60 will come to this place. We're able to insert. But I can't insert one more element. I can't insert one more element because queue is full. Now the condition for is full is designed like this. Returns true if rare is greater than -1. Rare -1 indicates that it is empty. Rare should be greater than -1. In all these cases, here, in all these cases, that shows that it has got, in all these cases, it shows that Q has some element. This is the one condition. And other condition is rare value, the next rare value is it equal to the next front value. We'll apply that rule here. In this case, the rare value is 0 here. After this, we are not able to perform insertion. The next rare value is 1. The next front value is 1. Both are same. We can't perform insertion. So in case of circular queue, it must be adjusted. Index should not exceed max -1. It should be set to 0. For that, you have to take modulus operation. This is the character statement. So what we'll do now, we'll remove one element. We'll perform one operation for deletion. Is it empty? Front value is not -1, rare value is not -1. Is empty is false. That means we can perform deletion. We are going to perform deletion. We are going to remove the next item, that is 20. Index is 1. Rare remains same. Operation is deletion. Item deleted is 20. Is success. Because is empty is false, so we're able to remove the item. After removing, this is the condition of the circular queue. Now we'll try again insertion, whether it is possible or not. Is rare value greater than -1? Yes, it is greater than -1. That means it has got some element. Next value of rare, the next value of rare is 1. Next value of front is 2. Both are not same. That means there is a place. Is full is false. It is not full because rare is greater than 1 is true and this is false. If both are true only we can say it is full, otherwise it is not full. So we can perform insertion. Front remains same. Rare is 1. Operation that we perform here is insertion. The item that is pushed into the queue is say 50. Let it be 50. It is success. 50 comes to this place. We have observed that queue is full. No more insertion is permitted. We see with the code whether it is possible to insert or not. We'll try for insertion. Is rare is greater than -1? Yes, rare is greater than -1. Rare plus 1. Next value of rare is 2. Next value of front. Next value of front is 1 plus 1, 2. Percentage max 2, percentage 5 is 2. Here also true. Both are true. That means here insertion fail. Is full is true. That means it is not possible for us to insert the new element. We are trying to perform insertion, inserting say 60 or so, it failed. So these are the two conditions that one should note: is empty and is full. Okay. This is the most recent inserted element 50. This is the most recently inserted element. This 60 was the oldest element in the queue, indicating that with the circle. This is the oldest element, this is a recent element. To do that, we can start printing the element from front position, next front position till the rear. We can write the recent element later, most oldest element earlier. In that way, you can write it. So you start printing from the next to the front. That means the front value now it is 1, 1 plus 1 is 2. So like this you can start printing 30, 40, 50, 60 or like that you can start printing. To print that, this is a condition used. For traversing, this condition is used. You start printing from front plus 1 to rear value. Here front value is 1, front plus 1 is 2, that value is 30 is printed first, incremented. Each time when you increase the index, you have to take the percentage. Like actually, the code is like this: the index percentage max. This is the way to perform an operation. The next index is 3. The item is 40. Next queue of 4. Item is 50. Next queue of 4 plus 1 is 5, percentage max is 0. In that way, it should be adjusted. Item is 60. In this way, all the item has to be displayed. Most recent element Q of 1 is 50. So here the item should be displayed from oldest element to the newest element. This is how the operations are performed. Same thing is explained here. We have seen insertion only if this part is false. If rear is greater than -1 and front is not equal to max. It is underflow if front equal to -1, rear equal to -1. Otherwise, at front plus 1, insert the new element. Display should start from front plus 1 to max. This is how the circular queue works.